Hello everyone, welcome back to my YouTube channel. So here we start with model 2, that is reviewing the literature and research design. Mm, Reviewing the literature. So first you should understand what is literature. A literature review is a survey of scholarly sources on a specific topic, and it provides an overview of current knowledge, allowing you to identify relevant theories, methods, and gaps in the existing research. So, writing the literature review that involves finding relevant publications, such as books and journal articles, critically analyzing them and explaining what you found. There are five key steps. The first one is search for relevant literature, then evaluate, then identify themes, debates and gaps, outline of the research structure, then write your literature review. When we write a literature review, we don't just collect the papers, we analyze them, we compare results, and we try to understand the gaps in the research so that a literature review is a survey of scholarly sources. If you can consider an example, if your project is on buck converter or solar vehicle, you need to know what types of converter have already been designed and which control methods are commonly used, what problems are still not solved. That's exactly what a literature review tells us. So, as I told, the first one is you need to search for relevant literature. There are five keys. So, how you are searching? For everything you have a search engine. So, if you want to search relevant papers, you can use Google Scholar, IEEE Explore, or Science Direct to find papers on your topic. For example, MPPT techniques for PV systems. You just go to the Google Scholar search engine. You can type MPPT techniques plus PV systems. You can get a number of papers in Google Scholar, and you can go to the IEEE Open Access Science Directs to find the papers. Then, after searching the papers for relevant literature, then evaluate sources. So, you should have give importance to strong sources like IEEE transactions or Elsevier journals, and avoid weak references like random blocks like ICRT. Sorry, I should not mention that all. You should avoid that. You should concentrate on IEEE transaction paper that will be having the more weightage and the more quality that you can get the sources for your related papers, and identify the themes, debates, and gaps. For example, many papers on MPPT discusses P&O techniques and incremental conductance, but only few papers test them in electric vehicle charging. That's a gap. You should have add few more MPPT techniques to charge the vehicles with the help of solar panel to fill the gaps, and outline the structure, that is organize your review in sections. For example, after the converters, control methods, then applications, like that. Then write your literature review. So as I told, don't just summarize the literature. Instead of that, compare which method is efficient, which one has limitations, and what is missing, and how to fill the data, how to fill the gap. Everything you should know. So these are the five keys you should remember for literature review. One is search for relevant literature, then evaluate, identify, outline, write your literature review. A literature review is not just copying and pasting summaries from papers. It's about analyzing, synthesizing, and critically evaluating. For example, if 10 papers talk about DC to DC converter for electric vehicles, don't just summarize each one. Instead of that, compare which method is most efficient, which one works best for real-time applications, so where do they fail. So that's all the things you should get, you should know, you should have to read the papers instead of summarizing something. So that reviewing the literature is nothing but it's a first step in any research. Before designing, for example, if you're taking before designing a buck converter or an IoT parking system, you must know what is already done and where it can contribute something new. Yes, it can feel time consuming and frustrating to read so many papers, but it's rewarding because it gives you a strong foundation for your research problem. And a good researcher, a good literature review doesn't summarize the same thing I told you now. So you have to analyze, synthesize, critically evaluate to get a clear picture of the state of knowledge of your particular research. And reviewing the literature preliminary task you can call in order to acquaint yourself with the available body of knowledge in your area of interest. So literature review is integral part of entire research process and makes valuable contribution to every optional step. So reviewing literature can be time consuming, as I told, daunting, frustrating, but it is also rewarding. So that no worries if time consumes while doing the literature review, but you should have some quality of work. So it functions are it that reviewing the literature brings clarity and focus to your research problem. Clarity and focus. The process of reviewing the literature helps you to understand the subject area better and thus helps you to conceptualize your research problem clearly and precisely. It also helps you to understand the relationship between your research problem and the body of the knowledge in the area. So improve your methodology. A literature review tells you if others have used procedures and methods similar to the ones that you are proposing. In that case, which procedures and methods have worked well for them and what problems they have faced with them. Thus, you will better position to select a methodology that is capable of providing valid answers to your research questions. First, bring clarity and focus to your research problem, then improve your methodology, then broaden your knowledge. That ensures you to read widely around the subject area in which you intend to conduct your research study, as you expected to be expert in your area of study. And it helps fulfill these expectations. It also helps you to understand how the findings of your study fit into the existing body of the knowledge. And the last one is contextualize your findings. Contextualize. When you do a research or a project, it's not enough to just get results. You need to show how your results fit with what others have already done. This is called contextualizing your findings. It answers the questions like, are your results similar to what others found? Are they better or worse? What's new contribution are you making to the field? These kinds of questions which will give you the contextualizing findings. Suppose, for example, suppose your project is the design of a buck converter for solar power PV systems. So you should find your finding should be your design achieves 92% of efficiency compared with others. Earlier papers shows 89 to 90% efficiency using conventional buck converters. Then contribution, what's new? You improve the efficiency from 90 to 92%, that is 2 to 3% because you optimized switching frequency and reduced losses. Then context in literature, your result shows that improving the switching strategies that can push the converter efficiency beyond the existing benchmark in PV system. This is what the plan contextualize, contribution, compare, findings. So here, what can analyze from the buck converter for solar PV. Others work if it shows 89 to 90 and you are getting 92% as efficiency, your contribution is 2% increase, then context is adding new knowledge. So this is what how to answer to your research questions, compare with what others have found, what contribution you have been able to make into the existing body of knowledge. How are you finding different from others? That is, how do you answer your research questions compare with means if you are reading the paper of buck converter, if it is having an 89 to 90% of efficiency, your contribution is to increase the efficiency by 2 or 3%, then for you to be able to answer these questions, you need to go back to your literature review, and it is important to place your findings in the context of what is already known in your field inquiry. So, procedure for reviewing the literature. Review literature, which means studying what others have already done in your area before starting your own project. So, why review literature? You need to review the literature to understand what is already known and to avoid repeating old work and to find gaps for new research. So, for example, if you want to study induction motor speed control, you must know existing methods like voltage control, frequency control, rotor resistance control before trying something new. For that, that is just example for reviewing the literature. So, procedure, search for existing literature in your area of study. Procedure, search. To effectively search for literature in your field of inquiry, it is imperative that you have in mind at least some idea of broad subject area and of problems you wish to investigate. So in order to set parameters for your search, you have to get search engines. There are two search engines we'll be having. One is from bibliography, that is from the textbook. Another one is for finding the journals. That is nothing but finding the textbooks and journals. So the sources are like books. So books are the foundation, and the advantage of book is good quality, reliable, well-structured knowledge, but sometimes outdated since it takes years to publish. If you have published one edition means to publish another edition, it will not take 1 or 2 days. It will take around 2 to 3 years to get a new edition. Example, if we can consider electrical machines by P.S. Pimra, it explains basic speed control of induction motor, but if you want the latest smart drive control, that may be not covers in a book. For that, you go to search for the journals, so that journals provide you with the most up-to-date information, even though there is a gap of 2 to 3 years between the completion of research project and the publications in a journal. So journals gives the latest research, advantage is updated, and it will give you current developments. Disadvantage can take 2 to 3 years from research completion to publications. How to find the literature? Books you are finding in library, journals you are finding in IEEE, Springer, Science Direct. If you're using the search engine, you can go for the Google Scholar, ResearchGate. These all are the finding of literature. So once after search for existing literature survey in your area of study, then we'll be go for review the literature select. Once we collect books and journal papers, the next important step is not just reading them, but reading critically. That means we don't just copy. We try to understand the main themes, methods, strengths, and weakness. So you should have to read the books or journal papers critically, but not just casually. Pull out main themes or issues from the books and journals and use notes, one sheet per one article or textbooks. You need to summarize by reading the things. For example, suppose you collected 3 papers on induction motor efficiency improvement. If the paper 1 discusses voltage frequency control basics, paper 2 discuss about introduce vector control, if paper 3 talks about fuzzy logic efficiency control, so your task is connect them together. That is, paper 1 should be linked to 2, 2 should be linked to 3, then you should have comparison table and all. You should not treat these papers separately. The linking should be there. So that build a framework to review literature. Select how we are building the framework. You are having a group finding under your interested themes, and you should write each themes is nothing but each papers. From each papers you should write the summarize or else what that paper represent in one sheet. Later you combined into a framework. For example, themes in induction motor literature survey could be traditional control method, modern control method, AML based control method. So that don't mix everything, group them. For example, traditional method versus modern method. This way you can clearly see the progress in research. And you should read critically with a particular reference to the following aspects. And you should note whether the knowledge relevant to your theoretical framework is confirmed beyond doubt. And note theories put forward the criticism of these and their basis, the methodologies adopted and the criticisms of them, examine to what extent the findings can be generalized to other situations, ascertain the areas in which little or nothing is known, the gaps in that exist in the body of knowledge. So for that, you can take one example for reading critically and particular with respect to following aspects. If you can consider induction motor efficiency improvement, for that you should know, does every paper agree that vector control is better than voltage frequency control? That is nothing but is knowledge confirmed beyond your doubt? Have some clarity. And what theories and methods are used? Any criticism? Someone will come and say fuzzy logic is good, but others criticize it as a complex. And can findings be generalized? A method tested in 1 HP motor, can it also work on 50 HP motor? That findings you should generalize. And what are the gaps? Few paper discuss cost effective of modern methods. This is just a research gap. So you can see these are some, you will read two short subject. These you can try it now. If you can read two short abstracts, discuss in your groups and identify the agreements, disagreements, criticism, generalization, and gap. Paper A, paper B, this or something. You can try it. So with these two abstract, if you want, you can take screenshot, abstract 1 and 2. So read both abstracts in your group and you can find what is common in both papers, what are the differences or criticisms, can results be generalized to other motors or industries, what research gap you can identify. So this is how the answers, if you want, you can screenshot and you can try it once. So after the second point, that is critical, review the literature selected. And the third point is develop a theoretical framework. As you have limited time, it is important to set parameters by reviewing the literature in relation to some main themes pertinent to your research topic. As you start reading the literature, you will realize that it deals with a number of aspects that have a direct and indirect bearings in your research topic. Use these aspects as a basis for developing your theoretical framework. The next is after developing theoretical framework, next you have to do a conceptual framework. When constructing your conceptual framework, by doing so, you will build a comprehensive model that will aid in justifying your study, clarifying the relationship we explored in the study, and aligning the design elements. So writing this in this order, writing up the literature reviewed in order to comply with the first function of literature review, that is to provide theoretical background to your study. Then list the main themes that have emerged while reading literature, convert them into subheadings. These subheadings should be precise, descriptive of the theme in question, and follow a logical progression. Now, under each subheading, record the main findings with respect to the theme in question, highlighting the reasons for and against an argument if they exist, and identify the gaps and issues. So, in order to comply with the second function of literature review, that is contextualizing the findings of your study, requires you to very systematically compare your finding with those made by others, quote them these studies to show how your findings contradict and confirm or add to them. It places your findings in context of what others have found out. This function is undertaken when writing about your findings, that is after analysis of your data. So if we can take an example, if there is a dual axis solar tracking system, here the theoretical framework defines. So the theoretical framework is built from scientific principles that explains how solar tracking works. For example, you should know the theoretical background of solar geometry theory, photoelectric effect, control system theory, motor theory, and these theories explains why solar tracking can increase efficiency compared to fixed panels. Similarly, conceptual framework is nothing but you have that shows how different parts of your system connect with help of block diagram. So conceptual framework is nothing but you have to write in terms of block diagram. So you can see the blocks from sunlight to LDR sensor you're connecting, then you're using microcontroller, after that motor driver, then solar panel is rotating, so increasing the power output. So independent variables, you should know that is a sun position. Control variable, you should know that is a tracking mechanism. Dependent variable, you should know that is a solar panel output power. So this block diagram is nothing but conceptual framework. So literature review writing, how you need to write? Just an example. Literature review organizes past studies into themes and shows research gap. For example, theme 1 to 4 you can observe here. So themes for solar tracking, fixed versus tracking panel. That study shows tracker give you 20 to 40% is more energy. If you can select say sensor based tracking and algorithm based tracking hybrid systems. So with the help of this, you can see LTR plus DC motors for sensor based, MPPT plus sun position for algorithm based. Hybrid means sensors plus algorithms for reliability. So gap examples, most low cost solar trackers use only LDR sensors as we know, but they fail during cloudy weather. Few works combine astronomical algorithms with LDR feedback for higher accuracy. Like that, you need to find a gap. Contextualizing finding means once you finish your project, compare with the past work. Your project dual axis, for example, if your project is dual axis tracker improved panel output by 32%, you have to study two. One is a fixed panel baseline and the other one is single axis tracker. In case of single axis tracker, 20% is improvement. If you are getting 32% in a dual axis means you will be having the increment of that is increase of 12% of efficiency compared to single axis, supporting the claim that dual axis tracking maximizes the solar utilization. That is what context. So you should know the meaning of research design. Research is like a planning a circuit before building it. You can call that as a blueprint. Just like designing an electric system ensures that it functions correctly, research design ensures that the study gives useful, accurate, and cost-effective results. And research design is like a plan or blueprint for how we will collect, measure, and analyze data in our project or experiment. It helps us stay focused on what we need while saving time and resources. Overall research design parts. The first one is a sampling design. That is nothing but how you choose data points. So this sampling design deals with the method of selecting items to be observed for the given study. For example, if you're testing a voltage across different components, how do you decide which points to be measured? Maybe you pick points across the resistor or capacitor. or the load. And the second design part is observational design, means the first one sampling design, there you'll choose the data points, that is collecting the data points, choosing the data points. In observation means under what environment or conditions data is collected, which relates to the conditions under which the observations are to be made. For example, are you measuring current at room temperature or at high temperature? The conditions affects the results. In terms of heat dissipation, you may get more losses or less losses, like that. That you need to observe. We can call that as observational design. And the third one is statistical design. That is how many samples you need and how to analyze them, which concerns with the question of how many items are to be observed and how the information and data gathered are to be analyzed. Example, if you are measuring a ripple voltage, how many measurements will you reliable results? How do you calculate the average or error? Okay. And the next is operational design. How to implement the sampling, observations, and data analysis, which deals with the techniques by which the procedures specified in the sampling, statistical, and observational design can be carried out. So, if you can use a simple analogy for research design, imagine you are building a solar powered battery charger. You first plan how many solar panels you need, that is called sampling. When and where you will collect sunlight data, that is called observational. How to process the data to check efficiency, statistical, and what tools you'll use to build and test the system, that is called operational. That is called research design. So these are the things just now explained. If you want, you can take screenshot from some point of view. So in brief, research design must at least contain a clear statement of the research problem, procedures and techniques to be used for gathering information, the population to be studied, methods to be used in processing and analyzing data. So need for research design, imagine you are designing a new power converter circuit for EV. If you don't plan how you are going to collect the test data, how much time you'll spend or what tools you'll use, you might waste resources and end up with unreliable results. So for that, you need a particular research design, need for research design. So the research design needs advanced planning. Advanced planning is very important. Research design helps you plan what data you need and how to analyze it. And you have to consider the objectives, staff availability, time, and cost for the discussion. For example, if you are testing a motor, you need to plan how many tests you have to do and what sensors to use and how much time it will take to test. And also, the research design needs. If you're not having a research design, there will be errors in design can ruin the whole project. A small mistake in planning can lead to unreliable results or wasted effort. For example, if you don't calibrate the sensor properly, all your data may be wrong. And this research design ensures reliability. A good plan makes sure that the results are valid and useful, and it is the foundation for meaningful research. But a poor design leads to wrong conclusions. Without planning, you may end up with a data that doesn't support the objectives or gives misleading results. For example, if you only test at low loads, you won't know how your system performs at peak loads. That's why you should know that poor design leads to wrong conclusions. And it organizes ideas and identifies problems early. A structured plan helps you review and refine the research before starting. Example, writing out your test procedure helps spot missing steps or equipment. And your research design, need of research design that allows collaboration. Others can review your research design and give feedback before you invest time and money, and it helps reviewers understand your work. The important thing is whatever the research problem you defined, whatever the research you are doing, the reviewer should understand what you are doing so that a clear plan allows supervisors or peers to assess your approach and suggest improvements. If you can consider a situation, a blueprint of a circuit is nothing but research design is like a schematic you draw before building a circuit. Planning avoids unnecessary real world errors. Observational design ensures you account for all the scenarios, that is testing, simulation. So these all are the need for research design. You can take screenshot from examination point of view. Future of good design. Next. A good research design is like a well-engineered system. It should be flexible, efficient, economical, and accurate. It's just like you want your circuits to perform well, it consumes less power, and be reliable. Your research design should meet similar goals. And it minimizes good design minimizes bias and maximizes reliability. The design should ensure that the data collected is accurate and free from errors caused by external factors, and it reduces experimental errors. The best design leads to result with less error, and it gives maximal information. A good design should give you the most insight possible, considers different aspects of the problem. A thorough design looks at all variables that can affect results, so that a research design appropriate for particular research problems. Usually it involves consideration of the following factors: the mean of obtaining information, availability and skills of researcher and his staff, the objective of the problem to be studied, nature of the problem to be studied, the availability of time and money for the research work should be known. And the important concepts relating to the research design: dependent and independent variables. A variable is something that can change or to be measured. Independent variables and dependent variables, for example, the input voltage to a circuit is independent, but the output current is depending on the input voltage. Extraneous variable is nothing but these are the other factors that can interfere but are not part of the study. For example, if you are testing how input voltage affect output current, but temperature variations also affect the output current, then temperature is an extraneous variable. That means a parameter which is affecting to your design, but it will be not a part of your design. Control means keeping things constant so that only the variable you are testing changes. Then confounded relationship, when something else interferes with your results and you can't tell what causes the change. And it is nothing but finding difficulties uh, for your variation of the output. And research hypothesis, a prediction you want to test scientifically. Experimental and non-experimental hypothesis testing, and experimental and control groups, treatments and experiment. So these are the important definitions. You can take screenshot for, from examination point of view. Confounded relationship, treatments, experiments, experimental units, and different research designs. So the different research designs can be conveniently described if we categorize them as a research design in case of exploratory research studies, and descriptive and diagnostic research studies, and design in case of hypothesis testing in research area. Research design in case of exploratory research studies. Exploratory research is like when you start working on new project area in electrical and electronics or any branches, but you don't know the exact problem or solution. You first explore to understand what the problem really is. So the purpose of this exploratory research study is about finding and defining the problem clearly, and the focus is to emphasize ideas and insights. And the flexibility is research design here is not fixed. You can adjust methods as new insights appear. So this is about research design in case of exploratory research studies. So exploratory research studies are also termed as a formulative research studies. The main purpose is formulating a problem for more precise investigation or developing the working hypothesis from an operational point of view. And it has three methods in context of research design: the survey of concerning literature, the experience survey, and the analysis of insights stimulating examples. Survey of concerning literature is nothing but reading IEEE papers, books, and reports. For example, reading research papers on buck converter for EV charging. Experience survey means talking to industry experts, professors, or professionals. Example, interviewing engineers in an EV company about battery charging problems. Analysis of insight stimulating examples means studying real world cases that inspires ideas. For example, looking at Tesla's charging stations as a case study to generate new insights. So the survey concerning literature that happens to be most simple and fruitful method of formulating precisely the research problem or developing hypothesis. Hypotheses stated by earlier workers may be reviewed and their usefulness be evaluated as a basis for further research. It may also be considered whether the already stated hypothesis suggests new hypothesis. So, in this way, researchers should review and build upon the work already done by others. But in case where hypotheses have not yet been formulated, his task is to review the available materials for deriving the relevant hypothesis from. And experience survey, as I told, you have to discuss with the people who had a practical experience with a problem to be studied. The object of such survey is to obtain insight into relationship between variables and new ideas relating to the research problem. The survey may as well provide information about the practical possibilities for doing different types. Insight stimulating means this method consists of intensive study of selected instances of phenomenon in which one is interested. So, if we can consider research design in case of descriptive and diagnostic research studies, descriptive research, that is nothing but which is describing the characters of particular individual or of a group, whereas diagnostic research studies determine the frequency with which something occurs or association with something else. You can take screenshot. I'll explain with the comparison. The design in such studies, formulating the objectives of the study, designing the methods of data collection, selecting the sample, collecting the sample, processing, reporting. You can see here research design for the two types of studies, overall design. See if it is a sampling design, exploratory of formulative here, the flexible design, but descriptive is rigid design. In case of overall design of exploratory, design must provide opportunity for considering different aspects of the problem, but here design must make enough provision for protection against bias. Sampling design, in case of exploratory, non-probability sampling design. In case of descriptive, probability sampling design. Statistical design, no pre-planned design. In case of descriptive, it's a pre-planned design for analysis. Observational is unstructured instrument. In case of descriptive, it is structured. Operational design, no fixed decision about the operational procedure in case of exploratory. Advanced decisions about operational procedures. Research design in case of hypothesis testing. You can just take screenshot. I will explain with the differences. You can see here. For all the three cases, exploratory, descriptive, and diagnostic, the meaning I just explained, the purpose of exploratory is to gain insights, formulate hypotheses, identifying variables to be studied further. In case of descriptive, it provides an accurate picture of a situation. It measures and describes the variables. In case of diagnostic research, it identifies causes of problem, test why certain relationship exists, suggest possible solutions. Nature of design, in case of exploratory, it is a flexible, open-minded, unstructured. In case of descriptive, it is rigid, structured, pre-planned. In case of diagnostic, it is rigid, structured, pre-planned. And if we can use typical methods for exploratory is literature review, expert interviews, focus group discussions, case studies. But in case of descriptive research, you can go with the surveys, questionnaires, observations, standardized tools. In case of diagnostic research, you can go with the surveys, experiments, statistical analysis, that is correlation, regression, etc. Sampling, usually small and non-representative. Here it is larger and larger. Data collected qualitative in case of exploratory, quantitative in case of descriptive, both qualitative and quantitative in case of diagnostic. Can take screenshot. Basic principles of experimental designs, the principle of replication, principle of randomization, the principle of local control. Principle of replication is nothing but replication. The experiment should be repeated more than once. Thus, by each treatment is applied in many experimental units instead of one. By doing so, the statistical accuracy of the experiments is increased. Conceptual replication does not present any difficulty, but conceptually it does. Similarly, randomization provides a protection when we conduct. You can take screenshot of this from examination point of view. This principle of randomization provides protection when we conduct an experiment against the effect of extraneous factors by randomization. Means, as I told, extraneous factors is nothing but if you can consider circuit, the temperature is a extraneous factor. So against of that, if you're conducting the experiments, then that we can call that as a randomization. Local control, it is an important principle again. Under it, extraneous factor, the known source of variability is made to vary deliberately over a wide of range as necessary, and it needs to be done. You can see here developing research plan. Important experimental designs. So here you have informal experimental designs, that is before and after without control design. So which means that a single test group or area is selected and the dependent variable is measured. The treatment is then introduced and then dependent variable is measured again. So the effect of the treatment, the level of phenomenon after the treatment, the level of the phenomenon before the treatment. For example, if there is a test area, so the level of phenomenon before treatment is X and the level of phenomenon after treatment is Y. In between, you are introducing a treatment so that the effect of treatment means output minus input. That is nothing but after treatment minus before treatment. Similarly, after only with the control design, before and after without control design. Here, after only with control design, which means two groups or areas, that is a test area and control area, are selected and the treatment is introduced into the test area only. The dependent variable is then measured in both the areas at the same time. Treatment impact is assessed by subtracting the value of dependent variable in the control area from its value in the test area. This can be exhibited in the following form. You can see here the control area is having two level of phenomenon. One is after treatment, other one is without treatment. So after the treatment is considered as white, and without treatment considered as a Z. So in the test area and control area, so in test area, if the treatment is introduced, then level of phenomenon after the treatment will be produces. In control area, the effect treatment effect will be after minus without treatment, that is y minus z. Before and after with control design. So in this design, two areas are selected and the dependent variable is measured in both areas for an identical time period before the treatment. The treatment is then introduced into the test area only. So once after introducing this into the test area, the dependent variable is measured in both for an identical time period after the introduction of treatment. The treatment effect is determined by subtracting the change in dependent variable in the control area from the change in dependent variable in a test area. This design can show in this way, can easily understand here y minus x minus of z minus a. That is level of phenomenon after treatment minus before treatment in test area, that will be subtracted by level of phenomenon without treatment minus level of phenomenon without treatment in a control area. And the second one is formal experimental design. Here it is completely randomized design, that is a CR design. It involves only two principles, likewise the principle of replication and the principle of randomization of experimental designs. It is the simplest possible design and its procedure of analysis is also easier. The essential characteristic of design is that subjects are randomly assigned to experimental treatments. For an instant, if we have 10 subjects and if we wish to test 5 under treatment A, 5 under treatment B, the randomization process gives every possible group of 5 subjects selected from a set of 10 an equal opportunity of being assigned to treatment A and treatment B. One-way analysis of variance, one-way analysis of variance is used to analyze such a design. Even unequal replications can also work in this design. And the second one is RB design, that is randomized block design. In randomized block design, the principle of local control can be applied along with the other two principles of experimental designs. And in the RB design, subjects are first divided into groups known as blocks, such that within each group, the subjects are relatively homogeneous in respect to some selected variable. The variable selected for grouping the subjects is one that is believed to be related to the measures to be obtained in respect of the dependent variable. The number of subjects in a given block would be equal to the number of treatments, and one subject in each block would be randomly assigned to each treatment. Can take screenshot from examination pointer. And the third one is Latin square design. It is an experimental design very frequently used in agricultural research. The conditions under which agricultural investigations are carried out are different from those in other studies, for nature plays an important role in agriculture. For instance, an experiment has to be made through which the effects of 5 different varieties of fertilizers on the yield of certain crops, say wheat, it to be judges. That we can call it as a Latin square design. In such case, the varying fertility of soil in different blocks in which the experiment has to be performed must be taken into consideration. Otherwise, the results obtained may not be very dependable because the output happens to be the effect not only of fertilizers, but it may be also affect of fertility of soil. Similarly, there must be an impact of varying seeds on the yield. To overcome such difficulties, the Latin square design, so-called LS design, is used when there are two major extraneous factors such as the varying soil fertility and varying seeds. Factorial designs are used in experiments where the effects of varying more than one factor to be determined. They are especially important in several economic and social phenomenon where usually a large number of factors affect a particular problem. So thank you. This is about model 2. Uh, you can take screenshots and refer the word question papers. Uh, Try to write the point wise with the standard words. So I think you can take screenshots and you can go with the materials. Thank you. Have a nice day. If you like this video, do subscribe and share. Have a nice day.